I'm Nick Ty. You see me in such fine quality, epic chemistry educational videos such as formulas, what does oxidation have to do with it, and do we really need to balance formulas? Okay, so this is a quick instructional video dealing with binary ionic compounds, balancing them. And we have to look at the oxidation numbers, but here's the thing, what are we talking about when we say oxidation number? Well, here's the thing. Atoms are either going to have a zero charge, like for example neon, that'll have a zero charge to it, okay, and the oxidation number is 0, but nobody really cares, okay, but on the other hand, hydrogen would have a +1. That's the oxidation number. We can look at sodium, that also has a +1. We have aluminum with a +3. Now, not all the oxidation numbers are positive because we can also have negatively charged atoms out there like chlorine. Chlorine is a -1 charge, for example. Bromine is also another -1 charge. Okay, well, what about something like nitride? Well, nitride has a -3 charge. So when we talk about oxidation numbers, we're referring to the charges here. Now, they're either going to be positive or negative on this. When we balance a formula, the charges must balance out to 0. Okay? Because if it's not 0, it's not stable. It's going to find something, grab onto something else in order to make it stable, in order to make it 0. So, let's take a look at some formulas here that we can do to balance things out. So let's go ahead and let's take a common one. A lot of people know this one. Good old sodium chloride. Now I'm going to show you a way how we can balance out sodium chloride. Okay? And it's not too bad. But we're going to need a little bit of information. Okay? For my students, I included something called an ion chart. That looks like this. Okay? Where I have it arranged alphabetically, I give the chemical symbol and the charge up there. Now, we're not going to necessarily use this because we already got some information here. So let's take a look at it. So what does sodium have? Well, sodium is an Na. Sodium is Na, but it has a +1 charge. Now, in the earlier videos, we talked about why is it that sodium would normally have a +1 charge? Because it wants to imitate neon, have its 8 electrons in its outermost valence shell, and thus be, quote-unquote, like neon, like a noble gas. But that's not happening. It drops the electron, but the moment it drops, it's that one electron, becomes a +1 charge. So that means it wants to find something that's negatively charged so it can go to it, so it can kind of get the electron back, but it's not going to be neon, but it's going to be a 0 charge. A little complicated, huh? Well, let's take a look at chloride. Now, you guys know chlorine. Chlorine has 7 valence electrons in its outermost layer, but in order for it to have its 8, it needs to pick up an electron from somewhere else. Doesn't matter where. So chlorine ends up having a -1 charge. Well, wait a second. What is chlorine trying to imitate? Well, it is trying to imitate actually argon. Where sodium's trying to imitate neon, chlorine's trying to imitate argon. It's imitating those noble gases. So this is why we're getting these charges. Now, by themselves, they're not stable. Okay? But I'm going to show you something called the Crisscross Method. Okay? And we're looking at binary ionic compounds. What do we mean by binary? Well, binary has to do with 2. Okay? 2, all right. Ionic, well, what are they talking about? We're looking at compounds that come together Usually it's a metal and a non-metal that come together, okay? Usually, for ionic compounds. That's in case there's some exceptions that I can't think of at the top of my head. But for what we're working here, we're pretty much going to work with metal and non-metal, okay, for our binary ionic compounds. So where's the binary part in sodium chloride? Well, there's the sodium, and we have the chlorine, which became a chloride because it picked up that electron. So our crisscross method goes like this. We're going to take the absolute value of our negative and we're going to transfer that down here. So sodium is going to have 1. We're going to have chlorine here that will also have a 1 because we're going to transfer that number down to here. So what does that look like for us? Well, what it looks like then, it looks like Na1Cl1. Now, in chemistry, when you are working with the formula, you don't show the formula. You don't show the number ones. There's no need to. So we're going to change that to NaCl, like that. So now, but wait, is it balanced? Well, let's check this out. Sodium normally has a +1 charge. Chlorine normally has a -1 charge. In this case here, we'll add them together and it should equal to 0. If it is a 0, you're balanced and you're good to go. So there it is, our final thing here for NaCl. And there you go. Good old NaCl. Now let's try another one. Okay? Let's try, we're going to try calcium. Let's see. Calcium oxide. Okay. Well, where's our binary? There's one here and the second one here. Notice it's got that IDE, so guess what? That means the oxygen picked up something. Well, what is the oxide ion? Well, in this case, it's O by itself with a -2 charge to it. Because normally oxygen has 6 electrons in its valence shell, that outermost layer shell, and it would like to have 8. That's why it's picking up 2 electrons from somewhere, anywhere. Now, calcium has a +2, okay, in this case, because calcium wants to get rid of its 2 electrons because they're extras. Because why? Well, it specifically wants to imitate argon. Oxygen, on the other hand, wants to imitate neon. So that's why they are doing what they're doing. Okay? They're being pretenders to the noble gases. Now we got that out of the way. Let's apply the crisscross method here. Again, absolute value bars. We're going to have Ca, we're going to bring the 2 down to here, okay, and we're going to have the O, and we're going to bring down the 2 to here. So we walk away with Ca2O2. Now, at this point, you notice that they're the same numbers on both sides, and like math, we get to reduce this down, okay? And we can reduce it down by dividing by a number that they both have in common. Well, what numbers do they have in common? 1 and 2. Kind of pointless to divide by 1, but we can divide by 2. So if we divide both sides by 2, we go with CaO, calcium oxide. Now, let's check. Maybe I'm fooling, but let's check to see if it is actually balanced. Well, calcium has a +2 charge. The oxide has a -2 charge. So +2 and a -2 gets us 0. So, ladies and gentlemen, it is balanced. Now, you'd say, but wait a minute. Do you have to reduce this down? Absolutely you do. Totally you need to. Okay, so it's not Ca2O2, it's CaO. That's calcium oxide. Okay, let's go ahead, let's do another example. of 1. Let's go with something more juicy. Let's go with, we already did calcium. Let's go for something like magnesium. Let's go with magnesium nitride. Woo! Okay, well, magnesium, again, you can get that from the ion chart. That's an Mg with a +2. The nitride is an N with a -3 charge to it. Yeah, nitrides are interesting little characters. Had to get my union-sponsored water break in there. So those are the charges that we have. Now, we're going to use the crisscross method once again because we know that this should work, all right? Now, there might be a question some people are thinking. Hey, how are we going to know which one goes first in our binary ionic compound formula? Typically, it's your cation, the positive ion that's going to go first. So we're going to go ahead. We have Mg and an N. So we're going to crisscross. We're bringing the 3 down. So we're making an Mg3. Here we bring the 2 down and we make the N2. Now remember the 3, we're going to make it an absolute value for it. So now you have Mg3N2. Magnesium nitride. That sounds like a fun little thing to play with. Okay? Now, but is it correct? This is how we got to check it out. So I know that magnesium each has a +2, so it's going to be 3 times +2 gives me a +6. Okay, so I got 6 charge of +6 on this side. Let's take a look on this side here. And notice I'm going to use a different color here. I'm going to go 2 times, the nitride is a -3. So 2 times -3 gets me a -6. So a +6 with a -6, that brings us to 0. That tells us we're balanced. Yeah! Okay. I hope this worked out for you guys. So remember, you can use the crisscross method, put the absolute value bars on your negative charge, okay? Bring it down to the opposite side like you're seeing here. If your numbers are the same and they're above 1, then you divide it down till you get something lower, okay? And with that, ladies and gentlemen, this is Nick Ty talking about binary ionic compounds with their oxidation numbers and how to balance a formula. Take it easy.